The next amino acid on the list is aspartic acid, and it's listed here as aspartate, which is the ionized form of it. So I'll go ahead and draw it here. Alpha carbon, carboxyl group here. And sorry, a little clumsy there. Let's finish this. And amino group on the left side. Okay, so aspartic acid is very much like glutamic acid. We're going to have a carboxylic acid group on the side chain. Finish. So this is aspartic acid, and when you deprotonate the side chain, you'll have a proton floating in the cytoplasm and a negative charge on the side chain. So this is L-aspartate, the left-handed version of it, which is what you'll find in proteins. So it is a negatively charged side chain at cellular pH. And here's aspartic acid and glutamic acid in this table here. Aspartic acid, pKa of 3.7. So in a cell, when it's pH around 7, it's a much more basic environment, so it's lacking those free hydrogen ions in the cytoplasm, and so most often these side chains will be deprotonated and negatively charged. The symbol for aspartic acid is D, and you can see here D and E are together as the two negatively charged side chains. Aspartic acid was named after asparagine. So it was named after asparagine because it was discovered by hydrolysis of asparagine. And asparagine was named after asparagus, so it's kind of slightly secondhand named after asparagus juice. Aspartic acid is non-essential. It can be created from oxaloacetate. See if I can show that real quick. So yeah, if you were to replace this ketone here with an amino group, you've just converted oxaloacetate into aspartic acid. So here's the alpha carbon and here's the side chain. I think one of the importances of, I'll just call it aspartate from now on, is that it's negatively charged, so it can attract a positively charged ion, and a lot of times that ion is going to be a metal ion. So there's a whole class of proteins, metalloprotein, which contain a metal ion cofactor. So it's I'm assuming an enzyme that requires this metal ion in order to be activated and function. One ion that's common is zinc. Zinc is very much like magnesium. They both are normally, the normal oxidation state is a +2 charge. So you have zinc with a +2 charge and magnesium also with a +2 charge. So one place that comes up is these zinc finger structural motif in proteins. So there'll be a zinc ion held to the protein. And then also magnesium is important. It says here all enzymes utilizing or synthesizing ATP require a magnesium ion. And that includes synthesis of DNA and RNA using ATP to synthesize those nucleotide sequences. Yeah, I think that's it.